Hi everybody, welcome back. This is a tutorial on how to do the lab assignment for this module. So this module is all about frequency distributions and charts. So what I'm going to show you is how to create a frequency table as well as some commonly used graphs that are used for summarizing and visually displaying the frequency data for variables that are both group variables, like categorical and nominal variables, as well as for variables that would be scale variables in the SPSS language, but would be equal interval or ratio variables. All right, so I'm just going to be working with the example that was presented in the textbook. And so I've already set up the data file. When you do your lab assignment, you basically have this similar data. You've got a professor type variable. Instead of student evaluation, you've got a GPA variable. I also have you create a participant ID. So your data will be ever so slightly different, but all of the procedures that I'm going to show you, as well as the interpretation, will apply. Okay, so I've just set up the data. This is consistent with what is presented in figure 4.2 on page 41. Just to point out one thing, which if I toggle here to the variable view, you'll see that professor type had to set that up as a nominal variable because it is a nominal variable where the values represent categories. What I've also done is I've already set up the values that are associated, or the label that is associated with each value. All right, so this is a step that you'll have to do in your assignment. You can go back and look at the tutorial for how to do that, but or you can look at the textbook as well. So just as a time saver, I did that. Another thing that I want to point out is student evals is a scale variable. When you're going to be working with GPA is going to be your variable. You need to make sure that that is specified as a scale variable. All right, so back to data view. The first thing that we're going to do is we're going to request a frequency table. And so a frequency table is just going to summarize the number of times that a value appears for a particular variable. All right, so this is under, you actually did this for a previous assignment, so this should be fairly straightforward, but we're going to go into Analyze, Descriptive Statistics, Frequencies. We'll move over both variables, and that's pretty much all we have to do. What I'm going to do is I'm going to use the paste command, and I'm going to do that because what I want to do is I want to collect all of my syntax. I want to collect all of my commands for running my analyses, because ultimately what I want you to do and what I want to be able to do is create a single output file that has all of the analyses that I want. And so if I capture all of the syntax, I can just highlight and select and run all the syntax, and that'll generate a single output file for me. So I'll paste that. And there it is. I got a question about this, so I'll point it out too. You'll see that there's this SPSS adds this syntax right here, dataset active, dataset 1. So this is a feature anytime that you work with SPSS and you have multiple data files open, what SPSS kind of needs to be told to do is activate one of those data files and then run the particular analysis that you're interested in running on that particular data file. So you'll see that the only active file that we have here is dataset 1. There's also this drop-down menu. So if I had another data file open, I could toggle back and forth, or I could use this drop-down menu to select which data file I want to run that on. So if you get rid of this, and I'll just get rid of it just to show you, it won't affect anything because you're specifying right here which data set is active. And you'll notice right here in the data file, so I've named it already, but you'll see these brackets dataset 1. So that's just kind of an internal reference for SPSS to use. All right, so let's go back to the syntax. Highlight it, play it. All right, there's our frequency table. So in the frequency table, just a couple things to point out. So we've got all the values of our variables. The frequency is just saying how many students indicated that they have that type of a professor. And so from this, we can see that the most common response was that students have a disdainful TA. The least common response is that they have a genius from another dimension. One thing that the textbook points out that I will as well is you'll notice these columns percent and valid percent. And you're like, well, what's the point of this? Because it's the exact same numbers. When there's no missing data, percent and valid percent will be exactly the same. Let me show you what happens when you have missing data, just as an example. So what I can do here, maybe, there we go. You'll see this little dot right here. That means that instead of having 20 students, we had 21 students, but let's just say that this 21st student didn't answer the survey, or they didn't answer the questionnaire. So I still want to reflect that there was 21 people that were in my research study, but I just didn't get an answer from this 21st person. Okay, I'll go back and let's run the same analysis. Okay, and you can see how the analysis changes ever so slightly. Okay, so now this says I have a valid N. So this is the number of participants that have a valid score on each variable. So I have my 20 students that had an answer for type of professor. I have my 20 students that had an answer for the evaluation. And then here's the one student that did not have an answer on either. And so you can see how the percent and valid percent changes. So the percent is the percentage of students out of the total 21 that gave that answer or that have that value. The valid percent is the percentage of students out of the students that answered the question. So percent is taking 3 divided by 21. Valid percent is taking 3 divided by 20. So which one is correct, which one is better? It just depends what your purposes are. If you want to say, hey, there was 21 people that I asked the question, and so out of those 21, 3 said study droner, which reflects 14.3% out of everybody, the 21. Alternatively, you could say, well, of the people that provided an answer, 15% of the people that provided an answer said study droner. So it's just a slightly different thing, but just to show you those two columns and how those are calculated. The cumulative percent is only based on the valid percent or the valid N. You'll notice here that you can kind of see that it stops, so we're not including this missing person. And that's the way that it works for our other variable as well. All right, so that's that. That's how to interpret that. Oh, just one other feature. This is more than you really need to know or do. But there are a couple different options for how your table appears. So if you go into format, one thing that you can do is you can order your output either by ascending values. And so the default in SPSS is just to say, by ascending values, it's going to take the values of your variable and present them in ascending order. So like 1 through 7, you recall with our categorical variable here, steady droner, was corresponded to a value of 1. So the values are going up in ascending order. But you can go descending order if you want. So if we wanted the evaluation to go from 7 down to 1, we could do that. The other thing you can do is you can sort by ascending or descending counts. So if we select that option and then hit continue, okay, what that does is it's going to sort the frequency table by descending count or descending frequency. So this is I still have that missing data in there, but this is a really quick way to be able to see, okay, what was the most common response? What was the least common response? So if you've got a variable that has a lot of categories, this can be really helpful, a very helpful way to say, hey, what was most frequently mentioned? You don't have to do that in your assignment. I'm just pointing it out as something that you might want to do. Okay, let me get this out of here. Oh yeah, and if you hit, try to hit delete, it won't go anywhere. So you actually have to just cut that row out. Okay, so no little dot. So now we just have our 20 students. So our valid n on both variables will be 20. All right, so that's how to do a frequency table. And just to point something out, here's our syntax. I've got that saved, right? And so if I wanted, I could comment this out. You don't need to, that this just creates a frequency table. There we go. All right, the next thing that we're going to do is we're going to create some graphs. So the first thing that we're going to do is create a histogram. So we've got our graphs drop-down menu. For some reason, there's this legacy dialog. I don't know why it's called legacy dialog. I've never known that SPSS has this category of legacy dialogs, and then this is where we actually get all of our different graphs and charts. So you're going to be working with this menu pretty much exclusively with this assignment. So what we're going to do is we're going to get a histogram first. A histogram is appropriate for interval and ratio data, okay, or scale variables. The idea is that we've got a quantitative variable that can be with the values arranged in ascending order along a continuum. So even if those values are discrete, okay, like number of trips to the doctors or something like that, where you can't have like a decimal, a histogram is still the appropriate graph or chart for displaying a scale variable in the language of SPSS. So let's go to histogram. So we're going to use the student evaluation variable in this example, include that there. And then what you're going to do is display the normal curve. And this is a way to get a visual idea of whether the distribution on this variable departs a lot from a normal distribution. If you haven't learned about normal distributions in your stats class yet, you soon will. But normal distribution is used quite a bit in statistics, but it is a symmetrical bell-shaped curve which has known properties of observations between really any two scores or values when they're in a standardized format. So anyway, so we've got that. Now, if you did everything correct, and you know you did, you could hit paste right now. But if you're not so sure, oh yeah, one other thing, sorry, title. So we're going to include a title as well. And so this is student evaluation histogram. It'll work if you don't put a title. It's just to make it pretty. It's just to tell your audience what you're displaying. Okay, now I didn't paste that, and here's the reason. You'll notice that I've got all this crap, right? Here's all these analyses that I've been running. SPSS by default is just going to append, your most recent analysis to your open output window. So what I don't want you to do is have a bunch of garbage in your output and make me guess what I'm supposed to be looking at. And so I did this on purpose because you'll notice that I forgot the normal curve here. So what I'm going to do is I'm going to go back to Graphs, Legacy Dialogues, Histogram, and say, oh yeah, normal curve. Okay, now I remember I've got it perfect. This is looking good. Paste. It got pasted. What happened? Where is it? Nothing happened. That's because we have to go to our syntax. Here's our syntax. And there it is. Okay, and then play. So now I've got the histogram that I want with the normal curve superimposed. And so this is something that I had you do on your lab assignment, is take a look at the distribution of the variable, I believe it's GPA, impose that normal curve, and then make some evaluation as to whether the data are follow roughly a normal distribution or whether they depart from normality because they could be skewed. By skewed, we're talking about non-symmetrical, and so that would mean that there is a tail that forms on one side of the distribution or the other. The ends of a distribution are known as the tail. So here we don't see any tails, right? But you might in yours. The other thing we can look at is to see whether the distribution is too skinny and tall or whether it is too flat and wide. That's kurtosis. So if we depart from a normal curve to the extent that the distribution is much more narrow and tall, that is leptokurtic. If the distribution is short and flat, that is platokurtic. I think about like the distribution kind of looks like you could put a dinner plate on top of it, platokurtic. So anyway, there are precise ways to determine the extent of skewness and the extent of kurtosis. All I'm asking for you to do is just do the eyeball test and say, hey, this looks pretty good, right? Is it perfect? No, but for the most part, those blue bars are fitting under the curve, most of it, so that's a pretty darn normal. This is a really darn normal distribution, by the way, when you actually look at distributions of variables. So just have an evaluation regarding whether your variable is pretty much normal or whether it would depart from normality in any way, either because there's a tail, that means it's skewed, or because it's too skinny, tall and skinny, or short and flat, that would mean it's kurtotic in some way. The other thing that this gives you, by the way, is this will tell you the mean, the standard deviation, and the n. So that's just some additional information that you can get on the histogram. And the other thing I'll point out here is that what's being displayed is the variable label that I entered. So if we go to our data here and we go to the variable view, you'll see the label, average student evaluation, range 0 to 7, just to show you guys some stuff. Okay, if we take that out and then we just run our analysis one more time, what happened? We just get the name of the variable. We don't get the nice label. We get the variable name. So, these are just some things to think about. We included a title. We've got a label for the variable, so you don't have somebody try to read your chart and they're like, what is Stu evals? Okay, student evals, I kind of get it. But this is average student evaluations range 1 through 7. So just some best practices in terms of using SPSS in terms of displaying data and things like that. All right, this is more, I was going to keep this one streamlined, but there's just so much I want to share. All right, moving on. Line charts, go to graphs, legacy dialogue. It's pretty much like the same basic sequence, right? Here we're going to get a line chart, simple, and summaries for groups of cases. So the good thing about this is that the default options are what we're going to be using. We go to define. Again, a line chart, very similar to a histogram. It's appropriate for a scale variable. So we're going to use our scale variable, and that's going to be our category axis. We're going to make sure that the line represents the number of cases because we're interested in displaying the frequency. We can add a title here, which is just student evaluation line chart. Continue. That's really all you have to do. Because I'm very confident that I did that correctly, I am just going to go ahead and paste it. If you want, hit OK, make sure you did it right, and then come back in through the menus, and you can run it again. But I'm going to paste that. Okay. Again, nothing happens. All you did is paste it, so you got to go into your syntax. There it is. That's what it looks like. Highlight it, play it, and that's what your line chart looks like. It's the exact same information as the histogram. You don't get the normal curve overlay that you do with the histogram. Some people like to look at data this way. It is literally the same information. You can even see that the shape is about the same. So when to use one versus the other, it doesn't really matter. Histograms tend to be preferred, at least in social behavioral sciences like psychology. There could be other disciplines that prefer these types of charts. One kind of odd thing, there's some oddities about SPSS. You'll notice that the y-axis or the vertical axis here says frequency, and here it says count. Again, same information. It means the exact same thing. Why would you label it differently? I don't know. But, just we can interpret the graph as saying what was the most common evaluation for a prof to get, right? So if we look at what are the tallest bars, so there was 5 students that gave their prof an evaluation of 4, and there was another 5 students that gave their prof an evaluation of 5. So we can say that the most common rating is an average rating of either a 4 or a 5. And we can get that exact same information here. So that's a line chart. Okay. Now, histogram and a line chart are appropriate for these scale variables, okay, which from your stats class would be like an equal interval variable or a ratio variable. Whether it's continuous or discrete, it doesn't matter. If we've got categorical data, okay, where the values represent categories, we use slightly different charts. So we're going to use a bar chart as well as a pie chart. So let's do a bar chart for type of professor. Okay, same thing. The defaults are what we need. So simple and then summaries we're going to define. So type of college professor, this is why it's very important that this is specified as nominal. So that's going to be our category axis. I'm just, in the interest of time, I'm just going to skip over the title. All of the defaults are where they need to be. So number of cases is what we want. I'm feeling, again, really good about this. So I'm going to paste it. Again, you can take a look at it, and if you're like, cool, this looks like what I expected, then I'm going to go back, use the menus, and then paste it one more time. All right, and there's the graph of that. Okay, so we didn't include a title, so there's no title there. This bar chart converges if we go all the way back up to our frequency table. Okay, so the most frequently selected choice for what type of college professor do you have was the disdainful TA, 5 people, and the least frequent was genius from another dimension. Great thing about a graph is that it's very easy to see what was most commonly selected and what was least commonly selected. So most students say they have a disdainful TA. Or I shouldn't say most students, but that was the most common answer. That was the most common answer, otherwise known as the mode. Again, the mode being appropriate for is a measure of central tendency for a categorical variable. All right, that one's done. Now we're going to do a pie chart. Same menu, graphs, legacy dialogues. This is going to get very quick and efficient for you. We'll go to Pi. The default summaries for groups of cases is what we want, so we'll define. Type of college professor is our nominal variable. We're going to define our slices by that variable. So if you think of that pie, each slice is going to be the number of students that selected that type of professor. Number of cases is what we want. I'm going to, just in the interest of time, skip over that title. I'll just hit OK for now. That's fine. Okay, so here we have our pie chart. So we've got type of professor, color-coded. Now, one thing that I have you do in the lab assignment, and one thing that is in the text as well, is putting some data labels in your pie slices. So the way that you do that is you double-click on the graph in the output window to activate this chart element. You can get into this chart editor. Now, there's a bunch of menus in here which are not at all intuitive what they are, but you'll notice you've got a new set of menus at the very top here. And so this is what I advise you to work in. So we're going to go into the elements menu. Okay, these are the elements of the chart. And then we're going to go to show data labels. So I think by default, SPSS, the thing they have displaying there is the count. So this is just the frequency of students that said that particular professor type. The other thing that I want you to move in there is the percent. So we select percent, and then we use this up arrow to move it up. If we hit the apply button, we can actually see what that will do. And then it's completely preferential as to whether you move one to the top or one to the bottom. See that? So you can have count at the top, apply, do it that way. You can have percent at the top, apply, and do it that way. Okay, so then close it, close this. And then we've got that in our output. So that's what I want you to do. I'll do that one more time. Okay, so what you have to do is you have to double click. You'll notice that that's going to give you a new set of menus up here. Elements. Oh, hide data labels. That was unexpected. Show data labels. Okay, there we go. And then that'll add them. Close it. And you've got it. Okay. Now, one thing that I did, and I swear yes, it was on purpose, is I didn't paste that syntax. So I'm going to go back to analyze, go back to graphs, legacy dialogues, pi. Okay. But kind of the nice thing about SPSS is that the last thing that you did in that particular menu is still there. So I'm just going to go back into the paste, and then I know that that is going to be in my syntax. So you can see the nice thing about the syntax here. I've got this big messy output file. What I'm going to do at the end, and you're going to see, is I'm just going to go back and I'm going to run all this syntax, and I'm going to get everything just in a nice, neat output file. Right? So one thing I do want to show you, though, is even you will still have to go back in doing this. You're going to have to go back and add the chart elements back in. So there's a way to do this in the syntax. I just haven't quite determined what that is. So that is one step that you'll have to do is make sure that you go back in and add your data labels. All right, and then the last chart that I'm going to ask for you to do is to create a graph of means. So we're going to go to graphs, legacy dialogues. We're going to go back to bar chart. Okay, so bar chart, it's the same default, simple, summaries for groups of cases, and define. You'll notice that your category access from before is still in there. You've got type of professor. What we're going to add, though, is we're going to say, instead of the bars representing the number of cases, we want the bars to represent means, And so then we have to tell SPSS, okay, of what variable? Here, it's going to be the average student evaluation. So what we're going to see is for each type of professor, what's the average student evaluation that that professor got. Your variables are going to be slightly different, but you're going to produce your bar chart of means in exactly the same way. Now, in your options, what you're going to do is display error bars, and then you've got 3 different choices for error bars. You've got confidence intervals, standard error, or standard deviation. Depending on where you are in statistics class, you might have heard of standard deviation, and you might not yet have heard of standard error or confidence intervals. I know for students in my class right now, we haven't gotten to this stuff yet. So that's fine. We're kind of in 259 outpacing 258 just a little bit. That's fine, not a big deal. The short of it is that what these confidence intervals tell you is the confidence level. It gives us a range of values within which we can be 95% sure that the true population mean will fall in. So whenever we use a sample, we don't have all the information from the population. So in calculating a sample mean, we say to ourselves, well, that might not be the true population mean. So this is a way to be able to say, okay, so let's kind of put brackets around, let's put endpoints around what would be the range that we could be confident in that the true population mean would fall in. That's what this is doing. Okay, so we select that, continue. I'm going to just skip adding a title in the interest of time, and I'm going to paste that. You don't have to do all the syntax pasting, by the way. I just want that to be clear. I use it because I think it's a great way to organize my work. And so here we have it. So one thing that you'll notice is that we've got error bars, and so these represent the 95% confidence interval for a particular mean. So the interpretation is that on average, in our sample, studied droners were rated a 3, but we can be 95% confident that the true population mean is within this range, and I can't quite read what it is from the graph. That could be, it depends on what the standard deviation is, but that we can say like our best guess is 3, but the true population mean could fall within this range. And you'll notice that the size of the error bars kind of reflect our confidence. The bigger that range is, the less confident we are. The smaller that range is, we can be more precise. Okay, this is a slightly smaller range, and we can say, all right, the average is whatever this average is, and then this is our degree of certainty. You'll notice that there's no error bars for genes from another dimension, and the reason is we have no variability for that particular professor type. So that professor type, the average rating, let's just go to our data, I don't need to guess. Genes from another dimension, the 2 students that said that they had genes from another dimension both rated 5, okay? So 0 variability, and so it's not possible to come up with a confidence interval if you don't have any variability. So there's that. Now the other thing that we can do with these error bars is we can compare the mean rating for our different professor types or for our different groups, and then ask whether the mean falls inside of or outside of the confidence interval for our other groups. So in this case, I'll point out that you'll see for disdainful TA, here's the average, and then our confidence interval goes up to 4. So we can be 95% confident that the highest rating that a disdainful TA would get at the population level would be 4. Here what we see is that the mean for genius from another dimension is higher than 4, old doom and gloom higher than 4, beloved statistics teacher higher than 4. This would be an indication that there is a statistically significant difference between these professor types in the student evaluation rating that they get. It's actually a very complicated rationale as to why that might not always be true, but it is a best guess indicator that if the mean, and that's what's being graphed here, we're graphing the mean, that's what we requested. If the mean for one group does not, repeat, not fall inside the error bar for another, that would indicate a statistically significant difference between those groups. Now, this is definitely not something I've covered in my class quite yet. So again, we're way outpacing it, but that's fine. It's just something for you to be able to take a look at the graph and interpret it. And then when you get to this point in 258, you're gonna be like, oh, cool, I understand that now, I hope. All right, so here's this big messy output with a bunch of garbage that I don't want. I'm just gonna get rid of it. Save the contents, no. Oh my God, I can't believe I just did that. It's okay, because I've got the syntax, and then all I need to do is run my syntax. It's all the analyses that I need, run it, and now I've got all the output I need and none of the output that I don't want. The only thing that I need to update is come back in here and make sure to include my data labels. Apply, close. There it is, okay? So what I want you to do is basically produce the same frequency table, the same graphs, the same charts, and I want it to be a single output file that only has the charts that you're requested to do. I don't want anything extra. And when you're, if anybody goes to become a research analyst or data analyst or whatever, and you need to present information to people, you don't want to be giving people stuff that they don't want. You only want the analyses that you requested to do, all right? So I'll save that, all right? So that's basically a tutorial of what you need to do, the graphs that you need to create. Hopefully you found that helpful. Looking forward to seeing what everybody produces this week. Thanks for watching.